profits, sales rather than profit. And in that case, we observe that the sales revenue maximizer always produce a higher level of output, but sells at a lower price level. That was one. Number two, we observed that a sales revenue maximizer charges a lower price as compared to a profit maximizer. Number three, that a sales revenue maximizer, profit maximizer. Number four is that a sales revenue maximizer and also a profit maximizer, both of them produce an output level where the price elasticity of demand is greater than 1. That's what we observed last time. Okay, today I want to go briefly about the effect of costs, increase in costs on both a sales revenue maximizer and also a profit maximizer. Regan, what's the problem, sir? Regan, you have put up the hand. Can I continue, guys? Can I continue, guys?
Yes, you can continue, doctor.
Yes.
Because I was doing a recap of what we did last time. Okay. Okay. So that was a recap of what we studied last time, and we gave several reasons why managers prefer focusing on sales rather than focusing on profits. We advise several reasons. We say that banks keep a keen eye and are more willing to lend money to those firms that are doing well, whose sales are increasing. Personal problems can also be easily solved when the sales are growing. Okay, and we say that increasing sales give prestige to managers, and as well as payment of top managers is much linked to the sales rather than the profit, because the profits goes in the pockets of the owners. So today, what am I going to discuss? So I've reached 160 so far I've joined. Today, what are we discussing? Guys, can we please behave? Okay. So increase in the fixed cost. What does an increase in the fixed cost occur? Now, if there is an increase in the fixed cost, what do we observe? If there is an increase in the fixed cost, what we observe that this fixed cost will lower the profit of a firm inward. So this is our profit curve. Here there is a profit, and here there is output, which I call X. So if this is the minimum profit that was set, this is the minimum profit that was set, what we observe that fixed cost, when there is a fixed cost, the profit curve lowers, profit reduces. So the profit curve will shift inward. I've only copied the profit curve from the above diagram, which we used last time. I've not drawn entire diagram, but I've copied the profit curve. What we observe is that a profit maximizer is not affected by an increase in the profit in the fixed cost. A profit maximizer will continue producing the same level of output Q pi. But his profit comes down also. But a sales revenue maximizer with the operative profit constraint is forced to reduce output level from XS to XS prime here. So basically, the profit maximizer won't be affected in terms of the equilibrium position. He will continue producing the same level of output, but his profit would have. But the sales revenue maximizer is the one that is affected by an increase in fixed cost because he has to reduce output level from XS to XS prime, or you may call them Q to Q whatever. So, but both of them, the profits lowers. That is the impact of an increase in fixed cost. What about the impact of, so basically what you have to know that the profit, the fixed cost does not enter into the profit maximizing equation. When you differentiate the profit, the fixed cost will always disappear. When you come to an increase in variable cost, what happens when there is an increase in variable cost? What do we observe? This was our original profit curve that the firm was having. This one. This is the original profit curve. When there is an fixed in the variable cost, remember that produce each unit of output. Or you want to produce an extra output, is going to reduce both. There is a reduction in his profit, and there is also a reduction in the output that is produced. So you find that both of the profit maximizer and the sales revenue maximizer will both of them affected, and they will be forced to reduce output. This one was operating at this point originally. Originally, sales revenue maximizer was operating at this point. Now is forced to reduce output. So what do we observe? That the reduction in output of a sales revenue maximizer is much higher than the reduction in output of a profit maximizer. Both of them reduce output, but the reduction for a profit maximizer is less as compared. So since both of them reduce output, we have to see that both of them increase even the price of the output they have produced. So that is the effect of a variable cost. If you have questions, raise up your hand now regarding this diagram. If you have any questions, guys, raise up the questions now. If you have any questions, guys, put up a hand. I can see two people have put up a hand. That is Semaganda Fred. Okay, Marvin, then Dan. Unmute yourself and speak to us. Marvin.
Yes, sir.
Yes, please.
Good morning, sir.
Morning, sir.
Good morning, sir. How are you doing?
Yes, I'm doing it.
So,
I would just like you to go back on the slide of both the fixed and
so I would request you to repeat for me this curve for the increase in value, which I have joined. So
Okay.
that's my
Then
request.
Matov Trevor. Matov Trevor, please speak to us. You are coming, Rebecca.
Yes,
Rebecca.
sir. Good morning, sir.
Mm.
Sir, I'm just inquiring. That straight line is the one representing the constraint.
Yes. Okay. Then, Fred Mutunji.
Yes, thank you, sir. I would just request to know if, like, you show us how the price increase.
How does the price increase? Okay. Next, I think you are done. Let me go back briefly. Here. Let me go to the chart. Why does the variable cost shift only the left? Okay. Let me try to answer you guys in that direction. Remember that I want to use this demonstration. Let me demonstrate from here using mathematics. We have that profit is revenue minus cost. But this cost has both fixed cost. So my profit will be equal to revenue minus the cost, which has both fixed cost minus variable plus variable cost. Okay, now this fixed cost has gone up. When it goes up, it means that the gap between revenue and the cost is going to lower. That's the meaning. If fixed cost goes higher, it means that the gap will reduce proportionately. So meaning that this gap here, profit is going to come down by this same gap.
Excuse me, sir.
Yes, please.
It's like you are illustrating something, but we are not seeing it.
Okay. Are you seeing it? Are you seeing my graph now?
No, sir.
Are you seeing my graph now?
Yes, sir, we can see.
Okay. Now, what I'm saying is that we have profit is the difference between total revenue minus total cost. That is fixed cost and variable cost. But now, this variable fixed cost has increased. So meaning that the profit is going to come down. When the profit comes down, this is my profit curve. This profit curve, and I'm saying this profit curve is going to come down. This inward shift, the gap should be the same. Make sure that the gap between these two lines are the same. Here, it should be the same because fixed cost is only the difference here. It is the same throughout. So the curve shifts inward. Okay? What we observe that A profit maximizer always operates at the maximum point of the profit curve. So the profit maximizer will continue operating at this point, which means that whatever case, he will continue producing the same level of output and is charging the same profit at same price. So there's no change in the price. So you find that the output is still the same, but his profit level has lowered here. Profit level has lowered. Now, the sales revenue maximizer, remember, this is the constraint. That's the minimum profit that was operate at this point, meaning that the fixed cost does not affect the profit maximizer because it will continue producing the same level of output. But a sales revenue maximizer is forced to reduce the output. Okay? That's what I'm saying from this diagram, that for him, he has to reduce output to meet the condition they have set for him. But this fixed cost does not affect the profit maximizer. Now, when you come to the variable cost is this one. Variable increase in the variable cost is, we see two things. One is that when the variable cost increases, because the cost depends on an output level, you see this gap here. I'm saying this curve will shift inward. You see it has shifted inward, but at the same point to the left. So the gap here between this and the gap here is not the same like the fixed cost. That's a major difference you have to note, that this curve both shifts inward and to the left. This one, it goes the other side. It doesn't come direct like this. No, like it was in the previous case. That's what you have to note. Now, when that happens, both, the other time it only affects a sales revenue maximizer. This one affects both. The profit maximizer was operating at this point initially. That is point A, or the output is A. Now is going to produce at the maximum point, which is B here. So this is both, the profit maximizer is going to reduce the output at that level. Okay. Now, the sales revenue maximizer, because this is the minimum profit that has been set, sales revenue maximizer is going to reduce in output from here. You can call it XS to output XS prime here. So this is the reduction in the output of a sales revenue maximizer. When you compare the reduction in output of a sales revenue maximizer is much bigger than the reduction in output of a profit maximizer. Okay? So which means that both of them, the variable cost increase affects both sales revenue maximizer and the profit maximizer, which is in contrast to the fixed cost, which only affected the sales maximizer because it reduced output. Here, both of them reduce output, but the reduction in output of a sales revenue maximizer is much higher than the reduction here. Okay? That's what we note. So both of them, since they have reduced output, they will increase the price. So that's what I can say on that slide. Okay. So that's what you have to note. Please note the difference between these two diagrams. Let me demonstrate them again here. I've said fixed cost, make sure that the curves shifts inward, but the gap is the same. I may not be straight, but the gap is the same here. That's what I'm demonstrating. This gap, make sure that it is the same throughout here. Then the variable cost, remember, if this is the first one, the second one shifts to the left here. So here the gap is bigger. It's not the same, but both of them have shifted inward. That's the difference. This is the variable cost. This is the fixed cost. The rest you can see. The reduction in output. This one was operates here. This one operates here. So the reduction in output. Remember, there's a minimum profit. So that's what you have to analyze. That's what you have to analyze from that diagram. I don't think that you have more questions regarding that. It is a simple Nakanjako Sharon. Let me give you just a few seconds. Please don't greet. Just go to the question. Please speak quickly. Unmute yourself. Sharon. Sharon. Unmute yourself and speak to us. Sharon.
Excuse me, sir. You had unmuted me. What I was saying is I would like to find out why the reduction in output for profit maximizer is bigger than that for us.
So there is this minimum profit cost that was set for him. So in order for him to continue, he has to be forced to reduce up to this level. Okay. Price, I divide by Q. Here, divide by Q. divided by 100. So put 100 here. What price will he charge?
300.
300. This one produced 125. What price, if you put 125 here, what price will he charge?
250.
To what?
250.
250. Yeah. Now, who charges a higher price?
Yeah.
Who charges a higher price?
Profit maximizer.
Maximizer. Who produces more output?
Sales maximizer.
Sales maximizer. Now, compare the profits as we stated them above. How do you get the profit?
Doctor, please ask members to mute.
You do what?
To mute. Some people cannot interfere.
Okay. Okay. Now, after getting that, compare the profit. Profit is basically profit remember, profit is revenue minus costs. You have the both revenue. If we start with the profit maximizer, he produced output which is 100. The total cost incurs when you put 100 here, you can get his total cost. When you put 100 here and 100 here, you can get his total revenue. When you put an output of the sales revenue maximizer here, you get the cost incurred by the sales revenue maximizer. Here you get his profit. This one should be simple. Compare the profits, part D. Because I've done everything here. Now, these parts, the other two parts, you leave them. This one, leave them out. You may not handle. But the last one, that one you may not handle. Just leave part out. Don't stress yourself. Maybe those mathematicians. Okay. Now I want to proceed to production functions. What are production functions? A production function is a transformation of physical inputs into an output. That one we defined even from the beginning under production theory. We said that is a transformation of inputs into an output, where we gave even different examples. So this production function can be both for short run and the long run. So we are looking at, in the short run, some factors are fixed, so it depends on labor. So this is an example of a short run production function where labor, you are able to change your labor to produce a given level of output. So what makes these production function shift from one level to produce a higher level same labor, but you are in a position to move to a higher production function. So that is a positive technological shock. When there is an introduction of new technology, you are able to use What about this short run production function? The short run production function, where one factor is fixed, it goes through, it gives us into through different shapes, which we can talk about above. This is your total production function. Then it declines. So, and here we derive another ratio which must have started in year one, marginal product and average product. Marginal product, it shows you a change in the total product over change in labor. In labor. That is marginal product, which must have started in year one. This diagram was actually taught in year one, so I'm just bringing it as a recap. And average product is just the total product divided by labor. Don't put changes. So we are saying it has 3 stages. Stage 1 is whereby your output will be increasing at an increasing rate, because and less of the variable cost. It begins from 0 up to a point where marginal product is meeting with average product. That is the stage 1 we are talking about. Up to a point where that is the stage 1 of production, and we say that output will be increasing at an increasing rate. Some people fail to understand increasing at an increasing rate. Increasing at an increasing rate. Let me give you a simple example to differentiate between increasing at a constant rate, increasing at an increasing rate, but also increasing at a constant rate. If I say from 1 is my first output, it doubles to 2, it doubles to 4, it doubles to 8. This one is increasing at a constant rate, doubling, just doubling, times 2. But if you come from 1, you go to 2, you go to 8, this is increasing at an increasing rate, because here the increase is times 2. Here the increase is times 4. So it is increasing from 1 to 2 to 4 to 8. But also the rate of increase is also increasing 2 to 4. Increasing at an increasing rate. But here, the rate of it is increasing from 1 to 2 to 4 to 8. So this one is also increasing, but at a constant rate. Doubling. That's why I'm saying here output is increasing at an increasing rate. Stage 2 It begins from where these two curves meet, average product and marginal product, at a point where marginal product is 0 here. And this one is referred to as an economic region, because any farm that is producing should always operate for maximization of profit, should operate within this region. Okay, it is more profitable to work within this region. And here your output will be increasing at a decreasing rate. Your output will be increasing at a decreasing rate. Okay? And the stage 3 is where there is a fixed factor. A fixed factor now is overutilized and there is more of a variable factor. Okay, and no one would wish to operate in this region. Why? Because as you employ more labor, your output continues reducing. It means that the extra labor you are bringing is useless. As you reduce labor in this region, output increases. So it is profitable to reduce labor until you come back to this region. So those are the 3 stages we talk about in the short-run production function. Now, what about the long-run production function? Remember, in the short run, we said that some factors are fixed, others are, someone is asking me, increasing at a decreasing rate. Let me just demonstrate for you, increasing at a decreasing rate. For example, if you start with an output which is 100, it increased to 150. It increased to 160. So here maybe, yeah, it has increased by 50%. Here it has increased by 50%. Do you accept that the increase here is 50%? But what about here? The increase is about what? The increase from 150 to 160, the increase is 10 divided by 150. The increase is about 6% here. So here it is increasing. It is increasing from 100 to 150. It increases again to 160, but it is increasing at a decreasing rate, 50% to 6% increase. So the rate is also decreasing. That is increasing at a decreasing rate. Am I clear? Okay. Now, in the long run, we said that all factors become variable, and in that case, we say that the production function, the farm is able to increase an output you're able to increase your output by varying all the various factors of production. And your production function, let me call it your output X naught, is equal to, is a function of 2 factors, capital and labor. Capital and labor. This one is not fixed, and this labor is also not fixed. Both of them allowed to increase. Now, when you allow that to increase, it implies that if this increases by a given factor, output, a given factor, let me call it T. And here output also increases by scalar T. If you are in position your output x1 to increase by that scalar t power n. That means that such a production function will be homogeneous. Okay? Or B, some people have used the B in this case here. Meaning that a function can be homogeneous of a degree n or B, whatever you want to use here, the power, which you abbreviate. So when it implies that when I increase my factor inputs by a scalar t, my output will also increase proportionately by the same scalar. That if my b is 1 here, we have constant returns to scale. What does it mean, constant returns to scale? That if I double my factor inputs, my output will double. That's the meaning of constant returns to scale. Doubling output is brought by doubling factor inputs. If my b is less than 1, it means that there is decreasing returns to scale, meaning that output increases less proportionately than the increase in factor inputs. Output increases less proportionately output increases less proportionately than increase in the factor inputs. And if this b is greater than 1, the power, then it implies that output increases more proportionately than the increase in factor inputs. And the firm experiences what we call increasing returns to scale. The best example which we use always is the Cobb-Douglas production function. Sometimes we say AK power alpha, L power beta. We may state it in that form, that if alpha plus beta is equal to 1, that is what we call the constant returns to scale. If alpha plus beta is greater than 1, that's what we call increasing returns to scale. If it is less than 1, that's what we call decreasing returns to scale. That we have talked about here in simple terms, or of long-run production function is what we call the Cobb-Douglas production function, which has those So when we talk about properties of linear production function, if you talk about properties of linear production function, properties of linear production functions. Someone has raised up a hand. Let me see. So long run, we have said that type in a chat, please. I'll respond there. Just type in a chat. So if we consider scale, I've stated already above that all factor inputs increase by the same proportion, output also increase by that proportion. That we have already stated above for constant returns to scale, that output will increase in the same proportion of increase in factor inputs. We can also say that if the production function is linearly homogeneous, the average product of capital and labor will remain unchanged with proportional changes in capital labor ratio, but also this is the zero. Constant. Now, clear? Let me give you a simpler number. Given that output Q is, I'm going to use that of constant returns to scale, is equal to K, my production function plus L, K plus L. This is my Q naught. That is my Q naught. Now, if I increase this, let my T, I choose to increase my T to B2, increase my output to B2. What will be the new output if capital doubles and also labor doubles? Q1 becomes 2K plus 2L. Okay? Now, Q1 can be simplified as 2 into K plus L. Do you agree? 2 plus L. But K plus L is my Q naught. So Q1 becomes 2, K plus L is Q naught, meaning that I've doubled my factor inputs here, my output has also doubled times the Q naught. That's the meaning of output doubling. That means that it is a simple production function we have been talking about with these properties. Now, when you talk about that, when you talk about this, it implies that output increases proportionately. So because this is 2 power 1, so that means that the function is homogeneous of a degree 1. Is K times L. Example, I choose a scalar, I double to factor inputs. If I double the factor inputs, it will be, I'm doubling, that means times 2. Capital is doubled and labor is doubled. My Q2 becomes so this one Q2 is basically 2 squared KL. 4 is 2 squared. So, but KL is Q1. So meaning that Q1, Q2 is equal to 2 squared times KL is Q1. Meaning that the function is homogeneous of a degree 2 because I'm able to factorize. But suppose you have K, Q is equal to K plus L squared. Is that function homogeneous? If you double factor inputs, it will be 2K plus 2L but squared. Are you able to factorize here? This will be 2K plus 4L. Are you able to factorize and relate with the original output? You that let me first clear. Q is equal to K plus L is homogeneous of a degree. DK, which is the marginal product of capital, which is equal to 1 also, if you differentiate this. And ULACM, what does ULACM say? That the total cost you incur, you are giving a wage equivalent to the marginal product. That is WL plus RK. This is the wage, the total cost. W is the wage. If you pay a wage equivalent to the value of the marginal product is 1 times L plus, here for capital, you have got 1 times K. Your total cost is equal to L plus K. But L plus K is the output, Q. So the total output will be exhausted. Please type in a chat, I'll respond. This plus. Douglas production function can be plus beta. This one can be homogeneous of a degree 1 or 2 or n, depending on alpha plus beta. Which other question is there? Production function, I think it is in position Can I entertain a few questions before I proceed? Put up a hand, then I want to end. Yes, just unmute. Don't waste time by greeting. Please go to the
of the other first calculation part you did, of where we differentiated.
Differentiated what? Marginal product and whatever.
Yes.
Plural theory.
Yes.
Okay.
Just explanation for
okay
where we have wage and
okay. Okay. How do you get the total costs? Okay. Let me do it from here. When I do it from here, first says that that is marginal product of capital times the capital and the production factor is exhausted, that your total cost will be equal to your output. This is Woolard theory. And I'm saying, how do you get a cost? I'm employing, I'm paying, for example, okay, I'm paying, for example, I'm hiring labor, I'm paying labor 500, and I'm paying capital 100. So this one is the price. These are the units I've employed, quantities. How do I get my total cost in that case? I want you to respond. Fixed cost, capital is variable, even labor is variable. But I'm saying I'm paying each worker 500 and I've employed 2 workers. The capital I'm paying 100, I've employed 3 units of capital. How do I get my total cost?
So you get 2 times 500 plus 3.
Yes.
Now, the wage is 500 here. Here the payment for capital is 100, equivalent to the marginal product of that factor. Your total output will be exhausted. By differentiating this function,
it will be 1.
1. What will be the marginal product of capital?
Yes.
Marginal product of capital times the units, marginal product of labor times the units of times L. What do you get?
K plus L is our output function.
Is
Q.
our Q, isn't it so?
Yeah.
Yes.
And the man is saying that if this is the degree, that
Yes,
have you seen
sir.
that?
Yes.
Yeah, you have seen that. So this is what we have demonstrated there. I want to finalize with this. Okay. So basically, output in the long run is represented by an isoquant. Output in the long run is represented by what?
An isoquant.
It shows a technically efficient method of producing a given level of what? Output. Have various what? Called a linear isoquant. Linear. Capital and labor. That is a linear what we call the smooth isoquant, which I've drawn initially here. A smooth isoquant. It shows you a level of stability between capital and labor. At a given point, it may not be possible to substitute capital and labor. That is the smooth isoquant. There is also what we call a kinked isoquant. Kinked isoquant, it has various kinks. This kind of form. It is used in linear programming. There is also what we call input-output isoquant. It is arrow-shaped like this. There is one fixed combination you can use or produce a product. There is no any other alternative here. This shows you that there is one method of you can produce at this combination. So those are the various types of isoquants you'll be looking at. Am I? The last two slides, which I'm ending my lecture there. If you talk about the production possibility of a farm producing many products, how do you represent it? Have you started about the PPF?
Yes, we did.
If you started about the PPF, well and good. Now, here, if you consider a farm that is producing many products, we can assume a farm that is producing two goods, and each good is produced using two-factor two factors of production, capital and labor, and each product can be represented by a set of isoquant with the usual properties. Isoquants, you have seen the isoquants. We can now always obtain the production possibility curve of a firm using the Edgeworth-Box curve. So the production possibility curve or the product transformation curve is a locus of maximum amount of products X and Y that can be produced from a given quantity of resources. Any point away from the Edgeworth-Box is inefficient. It is only those points on the contracts curve that are efficient. So let me demonstrate this with your assuming that these are the two products we are producing. Here we have the total labor that is available. Here we have the total capital that is available. That is going to be allocated in producing two commodities, A and M. Two commodities, A and the what? A and the what? A and M. A and M. So if you allocate this amount of labor, if you had 100, I've allocated 50 to produce commodity A, it means that the other amount of labor will be produced to produce what? The balance will be used to produce commodity what?
Commodity M.
Commodity M.
Yeah, if you have this 70 units of capital are allocated towards producing commodity A, the balance will be used to produce commodity what?
M.
Yes?
M.
M.
Commodity M.
Now, yes, good. You are good students. Now you are following. Of the contract curve. At the same point, decrease the product of commodity what?
A.
Commodity A.
That's this kind of analysis. So along with this point, what we are saying, there is efficient allocation of resources. The equilibrium is attained, the equilibrium zone is attained along this contract. Same concept, similar concept, but we'll be discussing about consumers, not producers. Am I clear?
Yes.
In that case, we'll be talking about indifference. We'll be talking about indifference what?
Curves.
Curves. So these ones won't be production possibility frontiers, but they will be indifference what?
Curves.
Difference curves. So don't misinterpret the diagram. The diagram looks similar, but the writing, this won't be capital and the labor. Am I clear?
Yes, sir.
The labeling won't be capital and what?
Labor.
Because in consumption, we shall be talking about commodities and so on. Is that okay?
Yes.
Now, here I've used another similar whatever, but I've said the commodities, let them become Y and what? X. At this point, you are producing an optimal amount of X and an optimal amount of what? Y. You can have equilibrium in production, but also equilibrium in
consumption.
So this is the indifference curve. This kind of indifference curve is tangent to the PPF, but is also tangent to the ISO revenue curve. This point A, it shows you allocative efficiency and production what? Efficiency. There is
efficiency.
Productive efficiency is when you are producing commodities along this PPF. Then a consumer is able to allocate and get also maximum utility, but also the farm is able to get maximum revenue along this PPF. That is the production efficiency and allocative efficiency along that. That would be the equilibrium of a farm producing multiple products. Am I clear there?
Yes.
Okay. And that marks the end of that chapter. That marks the end of that chapter. I'll have the next class possible on Saturday or Friday at 4. Those who have missed today, please come on Friday at 4. Have you heard?
Yes.
Come back on Friday. Inform everybody who has missed a class to come on Friday at 4. And the last class will be on Saturday. Saturday from 11 to 1. Have you heard, guys?
Yes.
The repeat of this class will be on Friday at 4 and also on Saturday. Make sure that you find appropriate time if you have missed. Inform those guys that have missed. That is my schedule. I've said the link remains the same. Yes.
Excuse me, sir.
Yes.
What does the ISO revenue line show?
ISO revenue line, eh?
ISO revenue line.
ISO revenue, it shows you the maximum amount of revenue you can get from selling the two products. Am I clear?
Yes.
I say when you are selling two products, you are getting different. For example, if I'm producing pancakes, if I produce different combinations of pancakes, I produce 2 pancakes, I sell 100. I produce 3 pieces of chapati, I get 1,500. How much revenue will I get in total? Chapatis 1,500, pancakes 200. That is the total 1,700. That will be the ISO revenue curve here. Am I clear?
Yes, sir. Yes.
Okay. When you are selling, the revenue you get is the ISO revenue curve.
Okay, sir. Okay. But could you elaborate more on you related it with the ICE? Was it the indifference curve?
Yes.
Yes. Could you please explain more the relationship with consumers? Yeah.
Okay. I'm saying these products you have produced, where are you selling them?
To the consumers.
To the consumers. So the consumers, what do they get in buying those commodities? They get
satisfaction.
Satisfaction. So I'm saying, if at this point, if there is both efficiency in production, but there's also efficiency in consumption. That is when the two curves are turning to each other, and also the revenue is at maximum. That's what I'm saying at this point.
Okay.
The consumer get maximum utility, the producers get maximum
revenue,
and also they also minimize resources in production. That's what I'm saying at this point, which is not possible at all other points. There is inefficiency. Yeah. Here we'll be getting less revenue. Though there is efficiency in production at this point, but the revenue is what?
It's less.
Less. ISO revenue curve will be lower. But even the utility which will be got at that point will be much lower.
Much lower.
Much lower. That's what I'm trying to communicate.
Okay, thank you, sir.
Some bit of more light on isoquants.
On what?
Isoquants.
isoquants, I said that when you are producing two commodities, okay, you can have an isoquant where you have perfect substability. As you move from here, you are using a given capital and a given amount of labor. Here you are using more capital and less labor at point A. At point B, you are using more labor and less what? Less capital. That means that you're able to substitute but to produce the same amount of output. That's the smooth isoquant. But this one, which is input output, it shows you that you cannot substitute capital and labor. There's only one method you can produce that output level. Am I clear? Yes. That's what I was trying to communicate. You guys, I want to allow more minutes for Dr. Taylor to continue with our class. I'm done with production. When we meet again next week, which will be the last one online, I'll be talking about game theory. Am I clear, guys?
Okay, that's very clear.
I'll be talking about game what?
So what
Game
about the
theory.
notes?
I sent you the notes, guys.
You already have the notes.
I sent you the notes.
We have the notes.
I sent the notes through Alex BA class. You contact through class coordinators, guys.
Yes, we got the notes, except Appeal.
To us.
He's lazy.
So, guys, have a nice day. Let us meet next week.
Yeah,
Those who have
sharing
missed can join on Friday and also join on Saturday. Please choose, tell them those are the last classes. Mzee Alex, you must have given out notes. Just speak to us in a minute and I go away.
As soon as possible. Send to the group.
Mzee Alex, for game theory. I said with Alex, you have the notes already, you guys. Don't buy handouts. I'm getting you, sir.
Yes, Doctor, I share the notes with all class coordinators. So it is either class coordinators didn't share or it is the students who are not taking initiative to get them.
But you must know your class coordinators and ask them where are the notes.
Okay.
Yeah.
So I've heard someone called, is it Mariam, saying they didn't share, but I shared the all notes. Let them get to coordinators and the coordinator get it to me in any case.
Okay. You share your number. Maybe they don't know your number.
Can I
Just
share
read
it
your number,
online?
sir. Just read. You read for
Okay,
them the number.
070.
You can get so many.
It is
Continue
070
reading, sir.
24 22 079. I repeat. 070. It's all right.
Right in the chat.
I said 070 24 22 079. I'm typing in the chat.
Wow, we're not getting it.
Okay, it is typed in a chat. Quickly, just go to the chat and read that for that number as I end the class now. Have you got the number, guys? But you must know your class coordinators, not disturb us. Just know your class coordinators. Good night.
Recording stopped.